Continuing with measuring arcs and then relating those to central angles. So you can use a central angle to find the measure of an arc, or you could actually also find the measure of a central angle using the measure of the arc. But for this minor arc right here, AC, this angle right here, the central angle ABC, is what's referred to as the arc of the angle. Sorry, the angle of the arc, I should say, or the arc is the arc of the angle as well. But if you know the measure of this central angle, let's just call it x degrees, then the measure of that intercepted arc, so this arc is said to be intercepted by the central angle, but the measure of the intercepted arc is the exact same measure. This would be x degrees as well. Besides x degrees, if I were to estimate that, maybe that's about 60 or 70 degrees. Let's just go with 65. If the measure of the central angle ABC is 65 degrees, then the measure of arc AC would also be 65 degrees. That's the measure of the minor arc. It's equal to the measure of its central angle. If I wanted to find the measure of a major arc, let me put a point D here. So arc ABC. And here's how I'd write it, kind of like the measure of an angle. So earlier I said, let's just say this is 65 degrees, this is 65 degrees. Then I could write the measure of arc AC, that's your minor arc, would be 65 degrees. If I wanted to find the measure of the major arc, I would actually have to take a look at the minor arc, 65 degrees, and we found that from the measure of its central angle. And then just take that away from 360 degrees. So I could write it like this if I'm showing all my work, 360 degrees minus 65 degrees. So the measure of the major arc ABC, even before we calculate it, it has to be more than 180, less than 360 because it's a major arc, and it would actually be 295 degrees by finding the measure of the minor arc AC and subtracting that from 360 degrees. And to discuss a postulate, the arc addition postulate is kind of along the same lines as, if you remember, the segment addition postulate and the angle addition postulate. The way that I stated those is for the segment addition postulate and the angle addition postulate, the sum of the parts is equal to the whole. So if I take a look at two arcs in the diagram here, for example, arc AB and arc BC, if I wanted to find the measure of arc ABC, which is a major arc, I could take the sum of the two arcs that make it up, that make up arc ABC. So that's equal to the measure of arc AB plus the measure of arc BC. The sum of the parts is equal to the whole, or I'll write out the arc addition postulate in words as well. So here's the arc addition postulate written out in words. What I'm going to go through is a specific example. Let's just say that we knew the measure of arc AB is 50 degrees. The measure of arc BC is 120 degrees. Then the measure of arc ABC, again, here's how I would write it. Little arc on top, little lowercase m right before it, just like when we're finding the measure of an angle, but 50 plus 120. So the measure of arc ABC would equal 170 degrees. Just like with congruent polygons, you could also have congruent circles. So if my circles P and Q are congruent here, I could write a congruent statement and write circle P is congruent to circle Q, but that would only be true if the radii of the two circles were congruent. So if I have a radius here, R, then the radius of circle Q would have to have the same length. So there's the congruent circles theorem. These two circles are congruent because they have congruent radii. You could also say that the circles could be congruent if they have congruent diameters, but really it's implied if the radii are congruent, then the diameters are congruent as well. And then since arc measures are the same as the measure of their central angles, you could have two minor arcs in the same circle, or possibly congruent circles, have the same measure if the measures of their central angles are congruent. For example, here's my circle, circle C. Okay, if I have a minor arc PQ, this minor arc right here, PQ, would have the same measure as the central angle right here. I'm going to call that X degrees. And then PQ, that arc measure would be X degrees as well. These two angles right here, as long as, if I name this R and T, PR is a diameter and TQ is a diameter, then these two angles would be vertical angles. Therefore, they should be congruent. This would be X degrees. And then this is the arc of the central angle. That would be X degrees as well. But notice the measure of the central angles for each of these arcs are congruent. So these arcs would be congruent as well. So I could say arc TR is congruent to arc PQ because the measure of their central angles are congruent.